Hello, ladies and gentlemen, folks of geometry. This is 3.5 part 2. So this is proof. Once again, proof, but it's proof with what's called CPCTC, and I'll get into what that means in a moment. But I want to kind of just reiterate that this is still a proof, and the CPCTC basically becomes like one step more in your proof. Okay, so as we look at this, I want you to realize kind of that you're dealing with a proof, but you end up taking it just one more step. And that's what I mean when I say that. First off, let's consider kind of what we've got for a proof. So if we have a proof here, we sketch our two columns. So we start writing down our given statements. Okay, so we've got JK congruent to MN given. That should be a 1 up here. 3KL congruent to NO given. And this you should understand kind of what you're doing. Then my last step, JKL congruent to triangle MNO, and that will be by side angle side. Okay, that one's really straightforward. The given statements give you enough information to prove that one. This one, I believe we've done a couple variations on this one. So once again, you start with your given statement, KN bisects JM. Let me move that. Two, JK is parallel to MN. And that is also given. And then kind of off you go. So these two are parallel. KN bisects JM. So bisects literally means cut in half. So you have this one and this one. All right, so what I can say then is I can say, you know what? If that gets bisected, that means JL is congruent to LM by definition of bisector. All right, that's what that means, definition of bisector. Now, what I might also say is you know what, angle J is going to be congruent to angle M, and that's because that they are alternate interior angles of parallel lines, so they are congruent. Okay, so this kind of goes back to unit 2, where you have two parallel lines, and then this kind of becomes your transversal. So this becomes this angle and this angle. And if these two are parallel, then they're going to be congruent to each other. So I know it's not easy to see in the picture, but I'm hoping that you kind of recognize it. Lastly, I'm looking at these two. So I would say, changing colors here, I don't want to do that yet. Angle KLJ is congruent to angle NLM. And those are going to be vertical angles. And so my final statement is, yeah, I've got enough to say JKL is congruent to MNL by angle side angle postulate. And that would be my answer. Okay, this one obviously a little tougher, a few more steps than the previous one. So now a new piece to add. So once again, you're given this first statement. You're given the second statement. So you're still, check, you're still starting with your given statements. But now here's kind of what's different. Your proof statement is no longer triangle congruent to triangle. Okay? It's no longer triangle congruent to triangle. Now it's part congruent to part. Okay, what I mean by part is it's either an angle or a side for both of those. Okay, so now let's look at what they're giving us. They gave us AC is congruent to AR, and they give us that 1 is congruent to 2. Okay, those are our given statements. Now they say CAL, now they're saying this angle is congruent to RAS for this angle. So what's the reasoning behind that is vertical angles. Now, notice this statement says triangle congruent to triangle. Triangle LCA congruent to triangle SRA. And that's true by angle, angle, side. But I'm not done. I'm not done. Remember, my proof, whatever my proof statement is, has to be my last one. So this is where I put CPCTC. And here's what that means. That literally means corresponding parts okay, corresponding, for those of you that might have forgotten, means same location. And if you might have forgotten, that was 3.2. Okay, so it means corresponding parts. So if you look at angle 3 and angle 4, angle 3 is here, angle 4 is here. They're in the same location. Now, next part of congruent triangles. Okay, we just proved that they were congruent in the step above. Okay, so that this is kind of what 3, 4, and 3, 5 part 1 were about. And then the final piece is are congruent. So here's what this says. Okay, parts of congruent triangles are congruent. Parts that match up in triangles that are congruent are congruent. Okay, which if you think about it, should make sense. Okay, if I have two triangles that are congruent, each piece that matches up, each angle, each side that matches up to another angle inside, those two pieces have to be equal. They have to be equal. And then in the interest of saving some handwriting, I just simply write CPCTC. And that's the accepted way to write it. So, corresponding parts of congruent triangles are congruent. So if two triangles are congruent, all their corresponding pieces are congruent too. Okay, so big giveaway is, what are you proving? Well, you're proving part is congruent to part versus triangle congruent to triangle. So CPCTC is going to come into play here. So once again, start with given. So angle S congruent to angle P, SH congruent to PE. Now they kind of give it away. Angle 1 is going to be congruent to angle 2 because of vertical angles. So they are congruent. So now I'm going to say my triangles SAH congruent to triangle PAE by angle, side. Notice that the sides that are congruent are not in between the angles. They're kind of the next angle going around the triangle. So finally, that should be 4. That should be 5. Finally, my last reason now is CPCTC. That's it. That's my answer right there. So again, I'm following through the statements. I'm trying to finish a proof. Now I just take it one step further. Okay, now off you go. Go play around with those. And I look forward to your questions. Thank you.